Hello, and in this video we're going to be looking at section 4.5, graphing rational functions. We're going to be taking a look at all of the different things that we did in the previous videos in this week and putting that together in a 5-step process to graph your graph by hand. So the things that we did with asymptotes, the things we did with domain or range, all of those things will be used in this video to help you graph a rational function. So we're going to start out with a worksheet problem that you have in your worksheet. We're going to take these 5 steps and work through this problem. The first thing you want to do here is find the domain. That's step 1. So since it is a rational function, we can't let the denominator cannot equal 0, or we can't get a solution. So what we would do is take this denominator right here and we would factor it as we set it equal to 0 or not equal to 0 to find those answers that are not in the domain. So in this case we have 2 factors of -6 that add up to -1. That would be -3 and +2. So we would go about solving this. We'd say x minus 3 cannot equal 0, or x plus 2 cannot equal 0. So that means x cannot equal 3, or x cannot equal -2. So that's our domain. Our domain would be all real numbers except the 2 numbers 3 and -2. All right, the next step in our graphing is to find the intercepts. Our intercepts happen when we have x and y equal to 0. So if we set our f of x equal to 0, or the function equal to 0, we'll find our x-intercepts. So if we do that, we get this equation equal to 0. Well, the only way this can occur is if the numerator is 0. So in a fraction, if your fraction is 0, the numerator is 0, and 0 cannot equal 6. So there are no x-intercepts. Okay, the y-intercept, though, is when we put in 0 for x. So we can actually find a y-intercept here. We have 0 squared minus 0 minus 6. We're going to get 6 over -6. So that's going to equal -1. So we have a y-intercept at 0, -1. No x-intercepts. Vertical asymptotes. Well, our vertical asymptotes happen if we look at this and make sure it's in reduced form, which it is. Then we would use these 2 values right here that would be our intercepts. So our intercepts actually come from our domain values. So these are going to come down here, and it's going to be x is equal to 3 and x equals -2 will be our vertical intercepts. So all the work we did with the domain will be actually helpful in our vertical asymptotes, since it doesn't factor and reduce. Both of these are asymptotes. Now horizontal and vertical, or horizontal or oblique asymptotes, is step 4. We look at the function. We have no powers of x up here, and we have an x to the second as our exponent in the denominator. That means that the numerator is less than the denominator, so our numerator degree is less than denominator degree. That gives us a horizontal asymptote at y equals 0. So we have 3 asymptotes and an intercept. So our final step here would be to use this information and draw a graph using this information and some points that we can find with our calculator. So let's start with the intercepts. We have asymptotes. We have two asymptotes that are vertical at 3 and -2. So 3, an asymptote down here at 3, and one at -2. And we have a horizontal asymptote at 0. So the axis here, the x-axis, is an asymptote. And we have one point that we can put on the graph, 0, -1. 0, -1 is an intercept. 0, -1. So it goes through that point. So now what we want to do is find a few more points using our calculator here. So we can use the table function to help us out here. And instead of evaluating it lots of different places, we can stick it into we can put the function into y equals, or y1, 6 divided by x squared minus x minus 6. Let me just verify that's what we were doing here. X squared minus x minus 6. Okay, so what we have. We can look at our table setup here, and I'm going to start my table at 0 and count by 1 so I can get some integer points on this. It's set at auto so that when I hit second table, it's going to give me some values for those points. And then I can plug these points into my graph over here to help me graph the function. So let's just move this over a little bit so I can look at it while I'm doing this. All right. So now that if I look at this, I can see this from behind here. We need to keep that there. Okay, so our first point is going to be -1, -1.5. So I'm going to take my value here at -1, -1, -1.5, and we'll put a point right here. -1, -1.5. We also have 0, -1. We already knew that. We had 1, -1, 1, -1, and 2, 1.5, -1.5. So we have that kind of graph. And then at 4 we're at 1, and at 5 we're at 0.42. So 5 we're at a little less than a half. Okay, and then we need to look at what happens on the negative side there. We have some numbers over here. So let's take a look at those. So at that point we have -3 is 1, -3 is 1, and -4 is 0.4. So it's the same. It's like a mirror over there. So this is what we have here for points. Now let's take a look at the graph and see if we can see this. We're going to set the window the same way. So that means the x minimum, x maximum looks like 8 and -8. So we're going to do that. -8 and a +8, and 1 is fine. -8 and +8. We'll look at what the graph looks like. It looks like we can see the graph here. So the graph looks very similar to what I have here. It's going to come up from here and approach the asymptotes. This is going to make a U-shaped here and go back down towards the asymptotes, and this one's going to be a mirror image of it over there. So let's graph that from here. So our graph would look like this. Come up. And we have a few points that so we know how close it is to the axis right here. We'll come down from the axis here, go through these 2 points, and travel towards the asymptote. Same thing happens here. We come from the asymptote up. It bends around here, hits those 4 points that we had graphed, and then goes back down towards the asymptotes here. This is our graph. So that's using your graphing calculator and the 5 steps. Some information from each step that we use to help graph this graph by hand.